want to talk about approaches, and this is more about like what we read in the article. So this is what I mean by modularization. So your data, software, and hardware are usually stuck together when you start. Like they might all be on one machine. And you want to do this, where you split them all. And it's turned out that even with mobile apps, so people say, oh, the web has lost. You know, native apps are the new thing, the gold standard. It's useful to pick that statement apart, because what people mean by the web is actually much more complicated than just saying the web, right? So you can argue that websites have lost and native apps are the way people want to do things. But in fact, the technologies of the web have won, right? So even native apps are talking HTTPS everywhere, right? Like everything talks to everything else by HTTPS. It used to be that they would just maintain open sockets. That's not what's happening anymore, right? If you have one thing on one computer talking to another thing on another computer, it is almost always talking HTTP between those two. So that means that you're using the pieces of the web technology stack to just work in different ways. And this is an important way to think about things, because it means that the lessons that you learn about how stuff gets from a web server to a website, to a browser, are still valid, right? So a native app is going to hit an API method, probably with URLs on it, and is going to return JSON, right? Almost all of these apps that we use are communicating in JSON over this, right? That's a web native representation, right? That came from the web. So those skills that you're acquiring are going to be valuable no matter how you deploy stuff. If you have, two computers talking to each other, you may want to just send stuff back and forth with JSON, because it's the way that stuff happens now. So this communication still looks web-like, even when you're not doing a website. This could easily be, that's why I said software, this could easily be a native app. It doesn't matter. You're still going to have a diagram like this. So data hosting. So how do you pick a platform that lets you actually scale, right? So these are three of the Mongo ones, just because that was one of the things I showed you. And you pick them by sort of cost, obviously, and what your budget is, but they're all pretty similar on cost. What you really care about is this stuff, right? Are the backup stuff included, or do you have a monitoring dashboard? What that lets you do is it lets you put your data someplace else. And instead of connecting to your database as localhost, you happen to be connecting to this totally other server that has your database on it. And this is the way that you'll hear people talk about architecting websites now. Your software is running here. Your images might be over here on a different computer. Your database might be over here on a different computer. Your JavaScript might be over here on a different computer. It turns out you don't actually care, and that's how you scale. So when I say where are you going to host your data, I mean you can just pay these guys, and they make a database, and they give you a URL to paste into your software. And then you're talking to a database on their server. And the cool thing they give you is this really nice dashboard to see what's going on, right? Like they can tell you, they give you these nice charts of like inserts over time. They give you this nice report of the error logs. It's way better than doing like a tail-f in your terminal, right? That is totally worth paying for. And many people even say, look, you should just start this way because it's so relatively cheap, right? Like I'm talking on the order of like $15, $20 a month for like the lowest version. Some of them even have free as the lowest, right? So there's a strong argument to be made, which I don't make yet, but I'm being convinced, that you should just start building this way. Start building by putting your database over here. Start building by putting your software on this virtual server, because you get all this stuff for free, that makes you build better software, right? Like the insights you get from these dashboards actually help you catch problems before they get out into the field, right? And that's actually totally worth paying for. So the same thing is true of where you host your software, right? Now picking software hosts, there are basically platforms, there's websites like Heroku, where you can create a project in any of these libraries and basically add in a little plugin and then easily deploy it to a Heroku server, right? In Rails and Flask and any of these things. They've built it so that you can easily deploy it to a server in the sky, right? A third-party server that they run. They spin up a new server for you. They set it up with their default libraries. You add a bunch of libraries, and you can just type something on your computer that deploys automatically to it, right? It just automatically updates your code there, and you get this ugly URL. It's like myapp5723.heroku app, whatever. And that's great for testing and sharing stuff with people. You can also pay more, and then you can actually host the real version of stuff there. So Heroku hosts a long list of platforms, like macro frameworks and micro frameworks. They've built support for a lot of those. And I think they have all those on their homepage. Joint is the same thing. Engine Yard is much more about Rails, as the train suggests. So there's tons more of these. These are just the 3 that I remembered off the top of my head that I've seen people use. And one of the things about Heroku is it's very friendly. Like their docs are written nicely, much more so than these 2, in my opinion. So it's a nice one. I also mentioned a while ago Cloud9, which is much more of an IDE, but lets you accomplish the development goal. Cloud9 is like Google Docs for code. So you can work on code together and deploy a server that's in the sky, and do that right from a GitHub project. So they're sort of going for a different market. They're going for the, like, use this as your IDE in the browser, not we're going to host this, but they happen to also host development copies of it. So you have a similar criteria here, right? Monitoring. Some of these things are so awesome that they can even do some profiling on your code, right? Which is stuff that Deval talked about. It can tell you what part of your code is taking longest to run, right? So you can actually find out what part of your code you might need to optimize. Sometimes you have to pay more for that. Sometimes you get that for free because they want you to pay more to be able to actually fix it. So that's really cool. So how does this all go together? It goes together like, this is the important thing to remember. This thing that we talked about before, physical versus virtual servers. So virtual servers, the idea is that they take this big chunk of hardware, right? An actual physical computer that has memory, hard drive, and CPU on it, right? And it slices each of those up. So it basically slices it up so that you get a certain amount of CPU cycles, you get a certain amount of the memory, you get a certain amount of the disk space that you can use for actually hosting your server. And then what they do is they basically just resell that giant server to lots and lots of people, right? They say, hey, you get this much of a slice, you get this much of a slice. Those are called virtual servers. And there's lots of packages that basically take a giant piece of hardware, and you get to tell it, I want 20 servers out of this. And each one gets this tiny slice of memory, this tiny slice of hard drive. It turns out that for a ton of simple web apps, you don't need very much memory and very much hard drive or very much CPU, So then that's how these things all work. You pay a lot for hardware. You pay less for a slice of hardware. That's the physical virtual thing. So then these are almost always Linux servers. Certainly in all the big ones, they're all Linux servers of one variant or another. So you have to get comfortable with the command line. The OS they run is often different. The one I still see being most popular in the lab is Ubuntu, out of all the Linux variants. People have complaints about it, but that's true of any distro. And I see that as the one that most people end up using, simply because there's a giant community base, I would say. Yeah.